The clock on the wall of the cramped workshop ticks with a steady, mechanical rhythm. Tick, tick, tick. The only other sound in the silence is the soft rustling of a fine piece of sheepskin leather. It is being rubbed with absolute precision over the surface of a monolithic crystal lens by a pair of rough, heavily callosed hands. This is Lam, a master optical lens artisan who has passed his 60s. His hair is half silvered, and his reading glasses rest low on the bridge of his nose. But the eyes behind those lenses retain a sharp, unyielding clarity. His room is cluttered with hand-drawn technical blueprints, yellowed by time, jars of ultra-fine diamond powder imported decades ago, and obsolete mechanical microscopes. This place feels like an oasis forgotten by time, tucked away in the heart of a city that is madly racing after automated algorithms and artificial intelligence. Suddenly, the old wooden door swings open. Kian, his eldest son, steps inside with a haggard face, his eyes heavily bloodshot from staying awake for multiple consecutive nights. Kian is the founder of a small medical precision measurement startup, a business currently teetering on the edge of total bankruptcy. He places a thick folder onto the dust-coated iron table, his voice trembling but filled with deep urgency. Dad, this is my absolute last chance. The Delta Technology Venture Capital Fund has just agreed to open a special funding round for domestic medical components. If I cannot prove the commercial viability of our self-designed laser blood vessel scanning system this time, the bank will seize our entire production workshop at the end of this month. Lam does not stop his hands immediately. His thumb continues to move with calibrated accuracy along an invisible curve on the glass surface, feeling the smoothness through the sheer tactile intuition of a man who has spent 40 years understanding the language of light. Only after finishing the final stroke does he place the lens onto a piece of black velvet, remove his reading glasses, and look at his son. What exactly do they demand from you? Kian sighs deeply, collapsing into the bamboo chair opposite his father. They do not just want blueprints anymore. They want to see a prototype operating with zero error directly in the conglomerate's main testing laboratory. The head of the evaluation committee this time is Hoang, the young chief technology officer of Delta. He is notorious in the industry for being a radical purist of absolute automation. Hoang constantly declares in the media that the era of manual craftsmen is dead, and that all human error is merely garbage to be systematically eliminated by AI algorithms. I heard that even their top internal engineers have to use imported laser scanning systems from Germany worth $5 million as the operational benchmark. A small enterprise using locally assembled components like ours is nothing more than a joke to him. Lam looks closely at his son's trembling hands. He knows Kian is a highly capable engineer, but the boy is being crushed under the weight of survival and a profound sense of inferiority when facing the massive numbers of a tech giant. The old man stands up, walks to the corner of the room, and unlocks a vintage oak box secured by 3 rotating mechanical combination rings. Inside the box, resting on a bed of vulcanized rubber, is a flat focal optical crystal lens no larger than the palm of a hand. Yet, its surface is so mathematically perfect and transparent that if one looks directly at it, it feels as though the glass does not exist at all. This is a lens that Lam carved and polished entirely by hand 20 years ago, a technical masterpiece he has refused to sell to anyone, despite 5-figure offers from mechanical antique museums. He places the oak box into Kian's hands. Integrate this into your central phase modulation lens system. Machines can calculate millions of polygons in a single second, but machines possess no tactile awareness of material expansion when a high-powered laser current passes through them. This crystal was hand-polished specifically to compensate for the natural thermal expansion of the material. It will keep your light curve from refracting or breaking, no matter how hot the system becomes. Kian stares at the lens, then at the deep calluses on his father's hands. He understands that this is not just a component. It is the accumulated honor and entire life's work of his father, placed into his final gamble. The next morning, inside the towering glass skyscraper of Delta Technology Corporation, the air is thick with the pressure of corporate metrics and industrial protocols. Huang, the 35-year-old CTO, dressed in a premium bespoke suit, stands with his hands resting behind his chair in the VIP observation room, looking down at the testing bay through a one-way mirror. Surrounding him are 5 assistants and modern geodetic engineers, each holding specialized laptops with screens continuously updating complex frequency analysis charts. When Kian walks in carrying his old wooden box and a raw laser scanner frame fabricated from generic aluminum extrusions, the looks in the room change instantly. It is the cold, dismissive gaze of people who believe they hold the absolute monopoly on the future of technology. Huang does not lift his eyes from his monitor, nor does he turn his head when Kian greets him, merely raising his wrist to check the time on his smartwatch. You have exactly 15 minutes to calibrate your system and execute the phase decay test of the laser beam through a simulated hydrofiber medium. If the phase deviation exceeds 0.03%, this funding session ends immediately. We do not have the luxury of time to play with hobbyist models from family workshops. Kian swallows hard, his throat dry and bitter against Huang's sheer coldness. He begins plugging in the data cables, his hands shaking slightly as he positions the aluminum frame onto the laboratory's optical alignment table. Everything seems to follow the technical protocol until Kian switches on the main laser power source of his modulator. On the large laboratory monitor, the curve representing the light beam begins to plot. But instead of a smooth, continuous trajectory, it fluctuates wildly and suddenly fractures right at the peak of the phase. A senior Delta engineer stares at the screen and lets out a cold laugh. Your system is suffering from severe thermal dissipation, failure. That homemade aluminum frame cannot withstand the structural vibration of a high-power laser diode. The light curve has deviated by a massive 0.1%. Huang spins his chair around, his eyes cutting like a blade straight at Kian, a patronizing smirk on his lips. I told you before. Pleased, makeshift technology, built on manual experience and cheap parts, only wastes our bandwidth. Our Delta X AI algorithm took exactly 3 seconds to identify this as an obsolete design that must be rejected. You may pack up your things and leave. Kian stands completely frozen in place by Huang's declaration. His entire world collapses around him, and the vivid image of his family's workshop being sealed by the bank flashes clearly across his mind. But just as he is about to let go and give up, his eyes fall upon his father's oak box, sitting silently on the table. The old man's words echo clearly in his head. Machines have no feeling for the material. Let the curve of light find its own path. Kian takes a deep, steady breath, his insecurity instantly vanishing, replaced by the sheer defiance of a man who has nothing left to lose. He looks straight into the eyes of the arrogant technology director. I am sorry, Director Huang, but my presentation still has 3 minutes remaining. I officially request permission to hot swap the central phase modulation lens with an independent component. Huang raises an eyebrow in pure contempt. Changing a component manually in the middle of a high-precision geodetic test? Do you think this facility is a flea market? But before Huang can order the security guards to intervene, a loud, piercing alarm suddenly blares from the central control room of Delta Corporation. The massive master monitor, displaying the metrics of their $5 million German crystal laser scanner, the absolute pride of Delta, instantly turns a flashing, violent red. A chief engineer rushes into the room, his face completely devoid of any color. Director Hoang. The core crystal scanning system for the national infrastructure bid has just suffered a catastrophic optical alignment failure. The computers are reporting a severe refractive error, but the AI's automated calibration algorithm cannot locate the physical point of deviation. The laser assembly is overheating rapidly, and if we do not shut down the entire system within 20 minutes, the $2 million crystal lens inside will fracture completely. The entire room instantly plummets into a state of absolute chaos, as their most advanced technological pride stands on the verge of exploding, with the national bidding deadline only hours away. The warning sirens continue to wail, tearing through the clinical silence of Delta Corporation's elite testing bay. Red flashing emergency lights paint the glass walls in a rhythmic, suffocating crimson hue. Hoang's calculated composure completely shatters as he stares at the master control monitor. The real-time telemetry from their German-made $5 million laser scanner is showing a catastrophic thermal runaway spike. On screen, the primary beam curve is no longer a straight line, but a chaotic, violently vibrating sawtooth pattern. The automated AI system is continuously refreshing, flashing a critical error code across the interfaces. Optical realignment failure, algorithmic compensation ineffective. The chief engineer's hands rattle against his keyboard, his voice rising in near panicked desperation. Director Hoang, the laser diode has reached 92 degrees Celsius. The internal thermal sensor indicates that the multi-layer monolithic crystal lens is experiencing micro-expansion along its central axis. The AI is trying to shift the mirror array to compensate for the refraction, but it cannot calculate the localized structural density distortion. If the core temperature hits 100 degrees, the structural tension will cause a clean thermal fracture right through the lens. We have exactly 18 minutes before the entire system becomes absolute scrap metal, and the national infrastructure bid begins in less than 3 hours. Hoang grips the edge of the metal desk so hard his knuckles turn white, his breathing growing ragged. This bidding process is not just a contract, it is the absolute foundation of his entire career and the ultimate validation of his automated infrastructure model. If the scanner fails now, Delta Corporation will be disqualified from the national project, and his entire department will face an immediate board investigation. He turns back to his team, his voice carrying a harsh, demanding edge. Override the AI manually. Force the mechanical calibration gears to shift 2 microns to the left. The chief engineer looks up, his eyes wide with genuine fear. We cannot do that, Director. Without a precise mathematical feedback model from the sensor, turning the gears manually is a blind gamble. If we miscalculate by even half a micron, the mechanical pressure will snap the crystal instantly. The room drops into a heavy, paralyzed silence, save for the persistent, mocking scream of the siren. All their advanced computing power, their multi-million-dollar infrastructure, and their complex algorithms are completely blind to the physical reality happening inside the sealed chamber. Kin stands by his small aluminum-framed prototype, observing the technical telemetry on the wall monitor with a strange, sudden clarity. The pattern of the light distortion on the screen is something he has seen before, not on a monitor, but on the stained wooden workbench of his father's shop. He remembers watching his father hold a rejected lens up to the sunlight, pointing out a faint, invisible ripple in the glass caused by a fraction of a degree in room temperature. His father's voice returns to his mind with absolute authority. When the light bends incorrectly, do not look at the calculation on the paper. Look at the heat in the material. Kian steps forward, his voice steady, breaking through the panic of the corporate engineers. The AI cannot fix it because it is treating the lens as a uniform geometric shape. But under 90 degrees of localized laser friction, the center of the crystal expands faster than the outer rim, creating a temporary convex magnifying effect that shifts the focal plane forward. Your software is trying to correct a lateral tilt that does not exist. You need to pull the entire emitter back by exactly 1.4 millimeters, not tilt the mirrors. Huang spins around, his face a mix of exhaustion and deep irritation, glaring at Qian as if he were an intruder. What do you know about monolithic geodetic crystal dynamics? You operate a garage startup using scrap parts from old medical monitors. My engineers hold doctoral degrees in optical physics from Zurich. Our software has been stress-tested through 10,000 virtual simulations. Qian does not flinch under Huang's dismissive gaze, his grip tightening on his father's old oak box. Your simulations assume perfect environmental conditions. But your high-power laser is heating the cooling fluid in the outer jacket, creating a thermal boundary layer that acts as a second, uncalculated lens. If you do not believe me, look at your third quadrant sensor array. The refraction index is curling inward, not outward. The chief engineer rapidly punches in a command sequence to isolate the third quadrant thermal data. A small localized graph pops up on the corner of the main screen. The blue line representing the index is indeed curling sharply inward, tracing the exact geometric curve Qian had just described from memory. The chief engineer turns to Huang, his voice breathless. Director, he is right. The boundary layer fluid is refracting the beam before it even hits the primary crystal. The AI algorithm is completely ignoring the liquid density change because it is programmed to assume the coolant remains at a constant value. Huang's jaw tightens, his pride warring brutally with the cold reality of the ticking countdown clock on the wall. 15 minutes remain. Even if we know the cause, we cannot adjust the emitter position manually with that level of precision while the system is under load. The mounting brackets are locked into the CNC chassis by automated hydraulic pins. To release them, we have to shut down the main power grid, which will lose our synchronization with the national bidding server. Qian takes a slow step toward the primary machine housing, his eyes reflecting the red warning one lights. You do not need to release the hydraulic pins of the main chassis. You need to introduce a physical counter, phase, medium into the external beam path to flatten the distortion before it reaches the main sensor. He opens the oak box, lifting the small, hand-polished crystal lens by its velvet edges. This is a flat focal phase compensation lens. It was milled manually to handle exactly this type of uneven thermal gradient. Let me place it in the secondary filter slot of your emitter head. Huang looks from the small, unbranded piece of glass in Qian's hand to his $5 million machine, his expression filled with intense skepticism and deep-seated corporate arrogance. You want me to put a piece of hand-carved glass from an unregulated family workshop into the core path of a military-grade geodetic laser? If that glass has even a single microscopic impurity or an uneven surface density, it will scatter the high-density beam instantly. The resulting back reflection will travel straight down the fiber optic line and blow the main laser diode to pieces. That will not just ruin the bid, it will permanently destroy the entire facility infrastructure. Qian holds the lens steady, his arm unmoving, looking directly into the eyes of the young director. My father spent 40 years miring this specific grade of crystal. He did not use a computer program. He used his hands to feel the microscopic friction of diamond paste against the silica lattice. This lens does not have impurities because it was allowed to cool naturally over 18 months in a sand bath, not flash-cooled in a factory mold to meet a quarterly production quota. Your machine is going to self-destruct in 12 minutes anyway. You can trust your blind algorithm until the glass cracks, or you can trust the hand of a master craftsman. The countdown timer on the wall blinks down to 11 minutes and 40 seconds. The ambient temperature reading hits 95 degrees, and a faint, high-pitched hum of structural stress begins to echo from the sealed steel casing of the German scanner. The high-pitched hum of structural stress, vibrating from the sealed steel casing of the German scanner, grows sharper. It sounds like a wire stretched to its absolute limit, waiting to snap. The room remains frozen under the suffocating crimson glare of the emergency lights. Hoang looks at the small, unbranded crystal lens in Keen's hand, then at the ticking countdown clock. 9 minutes and 42 seconds. Every scientific protocol he has ever studied tells him to reject this unregulated object. But the reality on the master monitor is undeniable. The automated system is completely blind to the localized thermal expansion. He looks at Keen, his voice dropping its arrogant tone, replaced by a cold, desperate edge. If this lens scatters the beam and destroys the diode, your startup will not just face bankruptcy. My legal department will tie you and your family workshop to a multi-million-dollar property damage lawsuit for the rest of your life. Do you understand the weight of what you are offering? Kien looks at the lens, his fingers steady against the glass edge. He thinks of his father, sitting alone in the dim workshop, his hands moving with rhythmic, absolute certainty. He thinks of the 40 years of silent, uncelebrated mastery embedded in this single piece of crystal. You understand, Director Juan. But if you do not put it in, you have already lost the bid, and your machine is scrap metal anyway. Let me calibrate the placement. Juan turns to the chief engineer, his face pale under the red lights. He gives a single, sharp nod. Open the secondary filter slot on the main emitter housing. Keep the main grid online. The chief engineer hesitated for a fraction of a second, his fingers trembling over the manual override switch. Sir, if we open the filter slot while the laser is active, the stray radiation. Do it now, Huang snaps, his corporate composure completely gone. The chief engineer punches the command sequence into his terminal. With a heavy pneumatic hiss, a small rectangular steel hatch on the side of the $5 million German scanner slides open. A thin, invisible draft of intense heat pours out of the slot, smelling faintly of ionized air and heated coolant fluid. Deep inside the chamber, a blinding violet spark reflects off the internal mirrors, the high-power laser beam operating at peak capacity. Kien steps up to the machine, his breath slowing down. Entering the exact state of quiet focus he had observed in his father since childhood. He ignores the corporate engineers, watching him with judgmental, terrified eyes. He ignores the flashing red warnings on the screens. Using a pair of non-magnetic titanium tweezers from his own wooden box, he slips his father's hand-polished lens into the secondary guide rail of the slot. The lens slides smoothly, fitting the precision German rail with a perfect, microscopic click. For the first 3 seconds, nothing happens. Then, a sharp, terrifying crack echoes from inside the machine housing. The chief engineer screams, shielding his face. The main monitor flashes a violent, solid white screen. The temperature graph shoots upward, hitting 99 degrees Celsius, 1 degree away from total structural destruction. Hoang steps back, his eyes widening with immediate fury, pointing a finger directly at Keen's chest. You ruined it. Secure it. Detain this man immediately. Shut down the grid. Cut the power before the whole unit explodes. But before the security guards can cross the room, The chief engineer stops mid-motion, his eyes glued to the refreshing telemetry numbers. Wait, director, look at the screen. Look at the fourth quadrant sensor array. The solid white glare on the master monitor suddenly breaks apart, resolving into a crystal clear, razor-thin violet line. The chaotic sawtooth pattern of the light curve instantly flattens out, transforming into a perfectly smooth, unbreaking geometric wave. The temperature reading at the core begins to drop rapidly. 96 degrees, 91 degrees, 84 degrees. The automated AI system, after 5 seconds of processing the change, removes the crimson error text from the interface. A clean, green status notification pops up. Optical alignment restored. Phase distortion compensated. System stable. The clinical silence returns to the room, but this time, it is the silence of absolute, paralyzed shock. The 5 engineers from Zurich stare at the monitor as if looking at a ghost. The hand-polished crystal, designed without a single line of software code, had effortlessly absorbed the uneven thermal gradient of the boundary layer fluid. It had flatlined the distortion before the beam could reach the primary mirrors, doing manually what a multi-million-dollar AI algorithm couldn't even locate. Hoang stands entirely still, his hand still pointed at Kian, his mouth slightly open. The arrogance on his face has completely evaporated, leaving behind a profound, humiliating confusion. How did a flat focal lens calculate the density change of the coolant? Our software required a supercomputer cluster to even approximate that matrix. Kian steps away from the machine, closing his empty oak box with a quiet click. It didn't calculate anything, Director Hoang. The surface of this lens wasn't mired to match a static mathematical equation. My father mitered it to follow the natural grain of the crystal lattice. When the heat rises, the lens expands in perfect symmetry with the material properties of the laser housing itself. It doesn't fight the physical change like your software does. It moves with it. The chief engineer looks at Kian, a deep, professional respect replacing the skepticism in his eyes. Director Hoang, the beam quality index is currently at 99.99%. This is higher than the factory specification from the German manufacturer. With this level of precision, our national infrastructure bid documentation is flawless. We are completely ready for the server synchronization. Hoang swallows hard, his face flushing red as he realizes how completely he had misjudged the situation. He looks at Kian's raw, aluminum-framed prototype sitting on the corner table, the very machine he had called garbage 10 minutes ago. He realizes that the entire core technology of his department was just saved by a man using tools from a garage workshop. He clears his throat, attempting to regain his corporate authority, though his voice shakes slightly. An impressive demonstration of material science, Mr. Kian. Your father's component has proven to be an effective temporary stabilizer for our internal systems. We will proceed with our national bid synchronization now. As for your startup's called-up capital request, as I mentioned, we require a comprehensive algorithmic infrastructure, not just isolated manual components. He is trying to push Kian back into an inferior position, trying to salvage his own shattered ego by reminding him of the corporate hierarchy. But before Hoang can finalize his dismissal, the main glass doors of the testing vibe sector slide open. An elderly gentleman with silver hair, wearing a conservative, unbranded charcoal suit, walks into the laboratory. He isn't accompanied by assistants or laptops, but the moment he enters, every engineer in the room immediately stands up straight, bowing their heads. It is Chairman President Vance, the ultimate founder and primary shareholder of Delta Technology Venture Capital. The man who controls the actual capital that Hoang only manages. Vance ignores the corporate executives, his eyes scanning the room until they land directly on the green status monitor, and then on the small oak box in Kian's hand. He walks past Hoang as if the young CTO were invisible, stopping right in front of Kian. Who brought this lens into this facility? Vance asks, his voice deep, quiet, and carrying an immense weight. Hoang quickly steps forward, trying to intercept the conversation. Chairman Vance, we experienced a minor cooling system variance during the preparation for the national bid. This startup applicant offered an uncertified manual component to temporarily stabilize the German machine. I was just about to have it removed to ensure compliance with our standard AI protocols. Silence, Hoang, Vance says, without even looking at his technology director. He keeps his eyes fixed on Kian, his expression unreadable but intensely sharp. He asked a question. Young man, who mired that crystal? The silence in the elite laboratory remains heavy, almost suffocating, as the green confirmation text on the master monitor continues to glow smoothly. Every eyes in the room shifts instantly from the data display to the silver-haired man standing by the entrance. Chairman President Vance takes 3 slow steps toward the testing counter, his presence completely taking over the high-tech space. Hoang immediately clears his throat, a layer of sweat forming on his forehead as he attempts to regain control of the room's hierarchy. Chairman Vance, as he was explaining, this is a minor technical optimization handled by our department to stabilize the core laser array before the official server synchronization begins us. We are fully within the safety parameters, and the algorithm is preparing to lock the final telemetry data. Vance does not turn his head to look at Hoang, merely raising a single hand to cut him off instantly mid-sentence. I did not ask you for a performance report, Director Hoang. I asked you who mired this crystal lattice. He steps closer to the terminal, his eyes scanning the physical shape of the small lens sitting perfectly inside the German machine housing. He looks at the microscopic, smooth curvature of the edges, which lack the jagged, precise laser marks left by commercial manufacturing tools. Vance's gaze then shifts down to the vintage oak box, resting open on Kian's workspace, recognizing the 3 rotating, mechanical combination rings on the lock. A look of profound recognition flashes across the old man's face, replacing his stern corporate demeanor with a quiet, solemn intensity. He looks directly into Kian's eyes, his voice dropping to a low, deliberate murmur. The 3-ring mechanical tumbler, the sand bath cooling pattern on the silica. Your name is Kian, correct? Is your father's name Lam? Kian looks back at the chairman, surprised by the sudden mention of his father's identity in this corporate skyscraper. Yes, sir, my father is Lam. He has operated his workshop in the old mechanical district for 40 years. Vance lets out a long, quiet breath, his shoulders dropping slightly, as if a heavy weight had just been lifted from his chest. He turns back to the master monitor, staring at the flawless violet light curve that has completely resolved the multi-million-dollar system failure. 40 years. And his hands still possess the ability to read the movement of light better than $100 million supercomputer matrix. Hoang steps forward again, his voice filled with an anxious, desperate confusion as he tries to understand the interaction. Chairman, do you know this craftsman? This is just an unregulated, independent workshop applicant that we were reviewing for a low-tier hardware component. So, their startup lacks the necessary algorithmic integration to match our modern infrastructure models. Vance finally turns his gaze toward Hoang, his eyes instantly turning as cold and sharp as industrial steel. A low-tier hardware supply loop, unregulated, Director Hoang, the very foundation of this entire venture capital firm, exists because of the man who mired that lens. 30 years ago, when I was trying to build the first Fiber optic communication lines across the northern delta, our imported signal amplifiers, kept fracturing due to thermal stress from the underground moisture gradients. Every international engineer we hired told us it was a structural impossibility, that the material limits of the silica had been reached. It was Lam who sat in a dark basement for 24 consecutive hours, using nothing but diamond paste and his bare thumbs to calculate the physical expansion curve by touch. He hand-polished the primary splitters that saved our first national data grid from total collapse. He refused to take a single share in my company, refusing to leave his workshop because he believed that the moment a craftsman starts looking at stock prices, his hands lose their honesty. Vance steps closer to Hoang, his voice rising slightly, carrying the absolute authority of a founder. You sit in this air-conditioned office, looking at virtual simulations and declaring that the era of human mastery is dead. Yet the moment your automated system encounters a real-world environmental variable that wasn't coded into your software, your entire million-dollar project freezes like a useless piece of plastic. If this young man had not brought his father's lifetime of experience into this room 10 minutes ago, your entire department would have been disqualified from the national project by noon. Hoang's face drains of all color, his mouth opening slightly, but no sound coming out. The realization hits him like a physical blow. The man he had spent the last hour humiliating and threatening with lawsuits was the hidden anchor behind the very billionaire who signed his paychecks. The 5 engineers from Zurich looked down at their keyboards, completely unable to meet Vance's eyes. Vance turns away from his executives, facing Kian with a genuine, deep-seated, "Your father did not send this lens to save my machine, did he?" Kian shakes his head quietly, holding his father's old wooden box closer. "No, sir. He sent it to save my system. He told me that machines don't feel the material expansion and that I should let the light find its own path." Vance looks at Kian's raw, aluminum-framed prototype machine sitting on the corner table, then at the thick project file that Hoang had previously pushed aside. He reaches out, picks up the file himself, and begins turning the pages with slow, deliberate attention. He looks at the detailed technical drawings, noting the way Kian had integrated classic mechanical tolerances with modern laser diodes. A faint, appreciative smile appears on the chairman's face. "You have your father's eye for structural integrity, but you have applied it to a completely new domain. This isn't just an assembly of cheap parts. This is an incredibly intelligent hybrid architecture." He closes the folder, looking directly at Kian. "Your startup is requesting $200,000 for factory expansion and initial medical compliance testing, correct?" Kian clears his throat, his heart hammering against his ribs. "Yes, Chairman Vance. That is the minimum threshold required to preserve our production equipment from the bank." Vance hands the folder directly to the chief engineer, bypassing Hoang completely. "Double the allocation to $500,000. Draw up an immediate, exclusive joint development contract between our primary medical tech division and Kian's workshop. The core manufacturing will remain in his family's facility. We will provide the capital, but the technical oversight remains entirely under the control of Kian and his father." The chief engineer bows immediately, his voice eager. "Understood, Chairman. I will begin the legal documentation right now." Hoang stands completely frozen in the corner of the laboratory, the red emergency lights finally fading away as the main room systems return to normal, revealing his pale, defeated posture in the stark white morning light. The clinical white lights of the laboratory reflect off the pristine marble floor, as Chairman President Vance stands completely unmoving. His sharp, dark eyes remain locked onto the small, raw, aluminum-framed prototype machine sitting on the corner table. Hoang's chest heaved under his tailored suit, his mouth opening and closing silently like a fish out of water. He looks at the chief engineer, frantically gesturing with his eyes for some kind of technical support. But the engineer quickly lowers his head, pretending to recalibrate a stable system metric. Vance takes a slow step closer to Kian, his leather shoes making a distinct, heavy clicking sound against the ground. Tell me, Kian, does your father still use that old wooden-handled lever loop to inspect the internal refraction lines? Kian looks up, a small, genuine smile breaking through his earlier defensive exhaustion. Yes, Chairman Vance. He still refuses to use the digital camera monitors. He says the electronic sensor flattens the depth of the crystal's core. Vance lets out a short, hollow laugh, a sound filled with deep, nostalgic regret. Of course he does. No, that stubborn old fool. He told me the exact same thing 30 years ago when we laid the backbone fiber lines across the northern mountains. He turns around slowly, his gaze sweeping across the 5 engineers from Zurich who are still holding their high-end laptops, frozen like statues. Then his eyes land heavily on Hoang. The young technology director flinches, his shoulders tensing instantly under the sudden, immense weight of the founder's presence. Director Hoang, Vance's voice is low, but it carries a terrifying vibration that seems to lower the temperature of the entire room. Yes, Chairman Vance. I am listening, Hoang stammers, his voice dropping an octave as he tries to hide the tremor in his throat. You built an entire 5-story automation department based on the premise that human intervention is a failure liability. You spent $14 million of our venture capital fund this year to purchase these German-milled scanners, claiming their integrated AI loops would eliminate the need for high-salaried hardware specialists. Am I remembering your quarterly board presentation correctly? Hoang swallows hard, his face shifting from pale white to a deep, burning crimson. Yes, Chairman. But the statistical modeling showed an efficiency gain of 92% across all standardized environmental testing parameters. Standardized parameters. Vance cuts him off, his voice flat, devoid of any anger, which makes it infinitely more dangerous. The real world is not a standardized laboratory parameter, Hoang. The real world has humidity spikes. It has dust particles from nearby construction sites that alter the cooling fluid density. It has unpredictable voltage fluctuations from the city grid that cause localized thermal expansion. Your expensive German machine was about to fracture a $2 million monolithic crystal lens because your software didn't know how to handle the smell of heated coolant. And what was your automated protocol's solution? Vance points a long, elegant finger toward the master monitor, where the green safety confirmation text is still cleanly displayed. Your protocol solution was to freeze the system, throw a genetic alignment error, and wait for a factory technician to fly in from Munich next Tuesday. By then, our national infrastructure bid would have been closed for 3 days, and our primary competitor would have locked the 20-year contract. Hoang looks down at his polished leather shoes, his hands shaking so violently behind his back that he has to grip his own wrists to stop them. He apologized, Chairman Vance. The algorithmic model didn't account for the boundary layer fluid distortion under continuous load. You don't need to apologize to me, Director Hoang, Vance says, turning his back on him with complete indifference. You need to apologize to the young man whose design you just called makeshift garbage and threatened to sue. The chief engineer shifts his feet uncomfortably, his eyes darting toward Kian, who remains standing silently beside his father's oak box. Hoang stands completely paralyzed, his intense corporate pride warring brutally with the survival instinct of an executive. To apologize to a low-tier startup founder, in front of his entire engineering staff and the chairman of the board, is an absolute, irreversible execution of his professional authority. But as Vance's silence stretches out, becoming heavier and more threatening by the second, Hoang realizes he has no choice. He turns his body slowly toward Kian, his neck stiff, his jaw clenched so hard a small muscle twitches beneath his ear. "Mr. Kian," Hoang says, the words tasting like ash in his mouth. "My previous assessment of your hardware architecture was premature. The alignment solution you provided using your father's component was highly precise. I apologize for the oversight and the language used during the evaluation process." Kian looks at Hoang, observing the raw, defensive humiliation radiating from the young director. There is no satisfaction in Kian's eyes, only a quiet, grounded tiredness. He remembers his father's workbench, where a broken lens was never treated with anger, only with a quiet determination to find out where the structural tension went wrong. "It's fine, Director Hoang," Kian says, his voice completely level, free of any petty triumph. "You trusted your sensors. I trust the material. We just look at the same light from different distances." Vance watches Kian's reaction, a deep flash of approval crossing his old features. He turns back to the chief engineer, his voice returning to its normal, commanding tone. "Prepare the contract addendum immediately. We are increasing the seed capital allocation for Kian's startup to $500,000, structured as an independent hardware development grant. There will be no corporate absorption. The intellectual property of their hybrid lens architecture remains 100% with Kian's firm. Furthermore, Kian's workshop is hereby designated as the primary technical oversight authority for our national infrastructure scanning network. Every German unit we deploy on the southern grid will be retrofitted with a manual compensation rail designed by Lamb's facility." The chief engineer bows deeply, his fingers already flying across his tablet interface to lock the executive order into the system. "Yes, Chairman. The legal draft will be ready for your signature within 30 minutes. Vance looks at Kian, reaching out to touch the smooth surface of the vintage oak box one last time. "Go home to your father, Kian. Tell him that the data lines are safe and that I still owe him a bottle of rice wine from 1996. Kian bows respectfully to the old founder, his grip tightening on the handle of the wooden box. "Thank you, Chairman. But I will deliver the message." He packs his aluminum prototype into his worn canvas duffel bag, zips it shut, and walks out of the elite laboratory. As the glass doors slide shut behind him, he can hear Vance's voice rising again inside the room, launching into a severe, comprehensive restructuring review of Hoang's entire department. But Kian doesn't look back. He steps into the polished steel elevator, pressing the button for the ground floor, feeling the heavy, metallic vibration of the skyscraper beneath his feet. The suffocating pressure that had been crushing his chest for the last 3 weeks is completely gone, replaced by a quiet, deep-seated urge to return to the dim, dusty workshop where the clock is still ticking against the wall. The steel elevator car drops smoothly through the core of the Delta Chok Choi, its digital floor indicator changing numbers rapidly. Inside the quiet, metallic enclosure, Kian leans his back against the polished wall, holding the vintage oak box tightly against his chest. His knuckles are still white from the tension of the last 2 hours, but his breathing has finally slowed down to a natural, steady pattern. He looks down at his worn canvas duffel bag, containing the aluminum-framed prototype, the system that had been labeled as useless junk just 90 minutes ago. A faint, ironic smile appears on his face as he remembers the look on Director Hoang's face when the $5 million German scanner was running at perfect specification using a hand-carved crystal. The elevator bell chimes softly As it hits the ground floor, the heavy doors sliding open to reveal the bustling, sunlit atrium of the main lobby. Kian steps out into the warm morning air, walking past rows of security turnstiles and busy corporate executives who are rushing toward their next high-stakes meetings. None of them know that the entire digital pipeline of their multi-million-dollar infrastructure bid was preserved by a single piece of silica cooled in a sand bath. He walks out of the glass tower and enters the crowded streets of the old industrial quarter, where the sleek skyscrapers slowly give way to low-rise brick warehouses and small mechanical repair shops. The smell of premium ozone and air-conditioned offices is replaced by the familiar, heavy scent of machine oil, cutting fluid, and hot metal. After 20 minutes of walking, Kian turns down a narrow